Now this figure 20-2A deals with connecting a closed delta hookup on transformers using single-phase and three-phase loads. Now notice in the diagram, L1 and the power transformer number 1 connects to the outside winding of the lighting transformer to the right side winding. That closes one end of the delta. Now we need to close end 2 of the delta. So we take the inside winding, which is the right side of power transformer winding number 1, and connect it to the winding of power transformer number 2, and that closes one end of the delta. Now to close the delta winding completely, we go to power transformer 2, and that winding connects to the lighting power winding, and that closes the delta. Now, starting with the XO, earth grounded, which is your neutral, it would, if you go through part of that winding to the right, it connects over to L1, and you obtain 120 volts to ground. Excuse me. And then if you, again, go through XO to the left of the winding and connect to L3, then you're going to have 120 volts to ground. Now the high leg would be easy to find then. You'd go to L2, and either way you go, right or left from that connection, you're going to go through 240 volt through 120 volt to ground. Go to your connection again, L2, and you go through 240 volt, right around to 120 volt to ground, XO. Now, electricians like to use voltage more sophisticated calculations. They say, okay, we have a 240 volt winding in the power transformer 2. We have a 120 volt winding connected to earth ground in the lighting transformer. So add 240 volt to 120 volt, divide that by the square root of 3, 1.732, you come up with 208 volt. Based upon utility voltage, or however you're obtaining your voltage, your power supply, then if it's high voltage or a little low, whatever it may be, that determines the high leg. Usually the high leg's about, in most cases, about 194, 198, something like that, based upon voltage drop and the run of the service and so forth, conductors. But basically, this figure 20.2a shows how to size those transformers. Step 1, single phase load, 20 kVA times 67%, 13.4. Now, not being too simple, the 67% comes from taking 2 and divide it by 3, because that's a 2/3 load there of that single phase. The 3-phase load then, 30 kVA times 33%, gives you 9.9. And again, not being too simple, 1 divided by 3 gives you 33%. Add them together, the values, you come up with 23.3 kVA. That's your solution for finding the lighting transformer, which we would select at 25 kVA using the Acme chart for their particular, their size transformers. Now, step 1, we want to find the 2 power transformers. So it's just basically taking 1/3 of each load. So we take 20 kVA at 33%, 30 kVA at 33%, and we total those 2 loads, we come up with 16.5 kVA. Now we could move up to a 20 kVA, so we'd have 2 20s there that we would have, and we'd have a 25 for the lighting transformer. But typically they would take all 3 and add them together at 25 kVA each, add those three 25 kVAs together, you'd come up with 75 kVA, and take 58% of that, and that you could use that value of 58% times the 75 kVA and feed other loads with that amount of current that would be available to you. And basically that's what this figure -22A is illustrating.